We're looking at question 37 on the AP Statistics Midterm Review Packet, and we're told that plot M indicates the coordinate x bar, y bar, the mean of the x values and the mean of the y values. And A through E are just the 5 father-son pairs. Now this question is asking us which father-son pair contributes the largest positive, there's a direction given to us, quantity to the correlation, which is your R, between father and son heights. Now one thing to really keep in mind is it gave us the idea of x bar, y bar. That's a characteristic of our least squares regression line. Every least squares regression line passes through the point created by your means for the explanatory and the response variables, x bar, y bar. So you can see I have it graphed there of where's my x bar, where's my y bar. It's actually important to do in order to solve this problem. So next, I'm going to figure out what am I really trying to do. I'm going to keep in mind what it's asking. It's asking us which contributes the largest positive quantity. So I am given a direction. And so when I give the direction, I'm going to focus right here. When I'm told positive quantity, I want to keep in mind what that means is it's contributing the most to the positive. So that means I have like a positive x deviation and a positive y deviation, or a negative x deviation and a negative y deviation. And the reason why is because of how we calculate our correlation coefficient. This was explained in the video dealing with question 36. I'll also explain to you after this. We're going through, you multiply your z-scores of the x times your z-scores of the y's for each observation. So positive times a positive is positive, and a negative times a negative is positive. And the reason why I say that is look how choice E, even though right here it looks like it's far away from our mean for x, it's contributing a positive to the x, but it's really contributing a negative to the y because it's below the y bar. So I'm going to eliminate E as one of my choices. So E is gone. Now what I'm really going to do is I'm going to figure out what is this question asking us. And so you can see I have 3 phrasings up above. I have which point contributes the most to R, our correlation. Which point deviates from the mean x bar and or y bar the most. And what that means is which is further away. And that's what deviates from. How far away is it from that point? So that's what we're looking at. And in other words, which would yield the overall largest z-score? And so you can see I have the formula. Like I said, this was talked about with question 36. Is R is calculated by taking your z-scores from the x and multiplying by the z-scores of the y for each observation and then add them all together. I'm multiplying by 1 over n minus 1 off to the side. So I'm looking for which one contributes the largest. And this is why if you're multiplying z of x times z of y, a positive times a positive is positive, and negative times a negative is positive. So this is where it contributes the largest positive. So that formula can also be used. Now in this case, that means I want to know which one's furthest away. And if I take a look at this, and I look at my table, what I'm going to do is I'm going to figure out, okay, what am I dealing with here? And what I'm dealing with is I'm trying to figure out which of these is further away. Now we eliminated E. E is gone. I'm not even going to look at it. Boom, it's not there. So if I look at which ones are furthest away, well, I can see that D is about right here for the X's, and it's about right here for the Y's. So that's not bad. Now C, no, it's not too far away. B isn't too far away. Now A is also far away. A is right here from the Y's and right here from the X's. So which one of those, A or D, seems to be furthest away from either mean or contribute the most? Now in this case, I think A is further away from x bar than D is. So when it comes to the x values, I think A is further away from the x bar. And when it comes from the y bar, I do think A is still further away than D is from y bar. So that's telling me A is going to contribute the most. Now let's go back to this. I could actually address this as what if I moved A so that it was far away still for the x bar. What if it was the same distance for the y bar? Now in that case, since the x bar is farther from the A, it would still contribute the most. So there's little tricks you can do here, but the answer to this one is A. Pair A, that father-son pair, is what contributes the most. The main takeaway here is that every least squares regression line passes through the point x bar, y bar, and if you're looking at which contributes the most to your R value, it's how far does it deviate from those values. In other words, the standard deviation, as I was saying, the z-score from those would tell you. And that is question 37.